Hello, my name is Lulu. I'm from Xendee, and I'm very happy to be co-hosting this webinar with Santos and Brett from Affiliated Engineers. So this is our agenda for today. We will start with some introductions. After that, I'll tell you a little bit about Xendee. Then I'll pass it over to Brett to talk to us about Affiliated Engineers. And then we'll discuss why decarbonization and net zero, look at some feasibility analysis and strategies, and close up with some case studies. Next slide, please. Well, I'm Lulu Arias. I'm the Director of Customer Success here at Xendee. Before working at Xendee, I used to work at the Boston Consulting Group, and there I led different projects, but mainly focused on mining and oil and gas. And that's one of the main reasons why I decided to join Xendee, because I wanted to transition into green energy and create some positive impact in the world. I've been here for 2.5 years, and during that time, I've been working closely with Xendee customers to help them optimize their microgrid and EV infrastructure. Santos and Brett, I'll let you introduce yourselves.
Hi, good morning, everybody. My name is Santos. I'm with Affiliated Engineers here in the Phoenix office. We're nationwide. I am a U.S. Navy veteran of 6 years. I was a submariner, electrician. So my familiarity with electrical distribution systems and nuclear power plants is pretty high. I graduated here at Arizona State University 3 years ago and have since been with AEI working on these decarbonization and net zero energy projects. Brett?
Hi, I'm Brett McQuillan with Affiliated Engineers. I'm a mechanical engineer and I lead our building performance efforts for our Phoenix office. I've been with Affiliated Engineers for 10 years and working on decarbonization in particular and net zero projects. So I'm excited to chat with you more today.
Great. So for those of you who aren't familiar with Xendee, we're the software company that helps companies optimize their microgrid and EV infrastructure. We have these 4 products that accompany you through the whole process. So from the discovery phase into the proposal, to the more detailed engineering design, all the way into the operation of the site. So let's say there's several sites that you're looking to decarbonize and you need to know where to start. Then you can use our discovery tool, and by entering the addresses and some information regarding load and the technologies that you're considering, you will get a rank order list that you can then order by ROI, CO2, and other important variables to help you make your decision. After that, once the sites are selected, you might need to create feasibility studies. And maybe you don't want to spend as much time or resources before any work gets actually contracted. And that's when you use Propose, which is our catalog-driven tool that helps you to quickly and accurately create feasibility studies and proposals that you can then share with prospects. After that, you might want to do this more carefully, get into some more detail, and that's where design becomes helpful. Here you can model outages, you can work with 15-minute interval data, you can run multi-year analysis, and a lot more. But I won't get into too much detail here because Santos will during his presentation. And finally, once the site is operational, you might want to continue to work with the same technologies that you did before. And so Operate basically uses similar algorithms, but incorporates real-time data to ensure that the runtime of your operation is constantly being optimized. That's it from Xendee. Santos, I'll pass it over to you and Brett.
Thank you. A little bit about Affiliated Engineers. We're a national design and consulting and engineering firm. We have 20 offices from the West Coast to the East Coast. We specialize in mechanical, electrical, and piping systems in particular from the building scale up to the campus and community level. So we do a lot of work with decarbonization, microgrids, net zero projects, particularly across science technology, campus scale projects, healthcare, mission critical, higher education, a wide variety of complex projects on organizations and institutional structures that are tackling these issues from a variety of perspectives. So yeah, very experienced, very interested in the subjects of decarbonization and net zero as well.
So let's jump into it then. So the decarbonization and net zero is the focus of this presentation. I'm going to be talking about how AEI has leveraged Xendee to be able to jump into these, but I really wanted to start with like the why we're looking at decarbonization and why we're looking at net zero energy. And a big portion of it is just because a lot of the sectors that we're dealing with at AEI deal in reducing the carbon footprint of the large facilities and or campus scale projects that we're involved with. So when we talk about decarbonization for this presentation specifically, we're really looking at those operational factors and how day-to-day operations are working to eliminate and reduce CO2 for campuses. And then when we talk about net zero energy, we're really talking about the investment in renewability, the transition away from natural gas, which is dominating a huge portion of the electric power sector, and kind of finding all those alternatives to meet the initiatives for achieving net zero. Brett, did you have anything you wanted to add to this?
No, I think that was great.
So I want to start with some methodologies, some ideologies when it comes to evaluating facilities for decarbonization. There's more than just what exists on the top level of what we're looking at. And starting every model with Xendee, you're able to place in your location and basically get a good footprint for what project area you're going to be working on. But it takes a lot more of that in the evaluation and the benchmarking of the type of facility you're looking at. So I have a few campuses shown here and a few different physical constraints that exist on campus, whether you're dealing with some concrete jungles whose soil quality may not be as good to build on, or you're dealing in some more natural preserve areas where really the ecosystems that are being preserved may be the reason that you have limitations for why you should or should not be investing in certain renewables. It really depends again on what's underground, not just the soil quality, but like water table, limitations that may exist. Also, like really evaluating what opportunities may exist, not just for present day technology investment, but for like the master planning that's associated with decarbonization. So maybe there's a plan for future growth that exists in a space where geothermal potential exists. And that's not a technology that's readily available today, but is something that goes into the process of decarbonization with leveraging the future growth anticipated by planning. These are a lot of the building systems that we tend to run into when we're talking about decarbonization. Again, highlighting that natural gas makes up a huge part of the electrical sector. Evaluation of mechanical and electrical infrastructure is super important when going into these decarbonization projects, because you're really not only evaluating what types of systems exist currently, you're evaluating the age and the infrastructure that's already in place, and considering what the conversion of a lot of those natural gas technologies into their electrified counterparts is really going to do. This can exist at large-scale gas-fired boilers or cogeneration plants, but it really does also exist when you're having conversations about those domestic appliances and what types of thermal needs are being met currently. So I bring up this slide just to show kind of a few examples of the different types of conversations that occur long before we jump into the model, but really into just like, again, the methodology for what it is you're trying to accomplish. Brett, you are mechanical led. I'm an electrical engineer. Is there anything more you'd like to say about this?
Yeah, obviously, as Santos said, there's quite a diversity of systems here. Obviously, there's lots of different players involved with the different systems when you're talking from heating to laundry to cooking to standby systems. So, having a process and tools to look at these various sources. It becomes really critical as we start to work through the different electrification or decarbonization options to replace, substitute, or go alongside these existing systems that we're working with.
So let's move into some of the tools that Xendee has available to us before we ever get into any financial or asset optimization. So I will say that many times when we're taking on projects, we may or may not have the data that we need for proper analysis of where the system currently exists. So Xendee has these data cleaner tools, which I'll start with first. And this data cleaner tool, let's see here, is wonderful for just taking in what meter data may exist for a large facility and then just spitting out the holes, the quality, maybe duplicates that may exist, things that you and me as an Excel wizard would otherwise have to code into your sheets and kind of figure out for yourself. This is such a great easy way to kind of put it in, check against it, and see what kind of quality data you have from the beginning. Xendee's load builder tool also allows us to take in 8760 data and then just create the conversations for what maybe your week, weekend, and peak demands really look like really early from the get-go. So again, yes, represented in Excel, it's wonderful, but if you're wanting to maybe be a little bit faster, putting it into a load builder really gives you a different perspective. Again, we talk decarbonization, present day construction, yes, but what about the future? So when we're talking about modeling the future planned growth of academic buildings or administrative buildings, or just a brand new facility otherwise, Xendee's load builder tool has a great toolbox for different load profiles that may exist depending on the type of facility. But then if you're getting another project that has specific requirements, you're able to also go in and build that out, again, without having to jump into Excel and really spend the time creating what it is you want. So I want to talk through the design strategies. Here in the Phoenix office, we use the design and the design expert mode the most when it comes to creating new projects. I've highlighted a lot of the technologies that we work on here in the Southwest region, and I'm super excited to even mention that small modular reactors are a conversation that we're having here at AEI, just for dealing in the conversion of, again, those cogeneration plants with a carbon or with a zero carbon alternative. Xendee is wonderful because it's able to provide you the time series data that it's assuming, again, from your GIS location, and then also in its outputs. If you're working on not just benchmarking how a facility is working in general, and you're looking for a resilience metric, it has the ability to be able to, optimize for these different outage scenarios, and then you can have those conversations. Again, a lot of what Xendee is providing here is just the ability to be able to model and represent the way that a facility might be operating currently and how it wants to operate for the future assets it's investing in. I bring up expert mode on this slide because even though expert mode isn't like your default start point, when you are going through specific program requirements, you may require something like expert mode for your project, which is an easy conversion of your current design with a click of a button. But I think one good example that I can bring up is the way that I would expect a battery energy storage system to operate. Xendee is going to optimize its operation, and it may not be the simplest or most real scenario that a client or owner may expect for their battery system to work. Xendee is able to give you the zeros and ones, the permissibility of when batteries are going to charge or discharge as just one example of the way that expert mode may be leveraged instead of just design. What I appreciate about Xendee is that it's not an all-in-one solution. Here at AEI, again, between the Phoenix and Southwest region, we're using helioscope, which is just a little bit more fine-tuned way of modeling solar and being able to represent it to customers. And then from there, if we're using helioscope, we can place that output into Xendee using its helioscope converter. So this is another data tool that's available for Xendee users, for other people who may be pursuing the installation of solar. I think this is a great way to be able to take a helioscope model, communicate that with a future solar vendor who may come onto the project, and then also be able to take from a solar vendor who's been brought onto the project and update a working model for what it is you're trying to represent. So I'll talk through rates and tariffs. Again, super appreciate Xendee because based on your GIS location, you can use this geneability tool to figure out which utilities are available to you, which present day rate structures are currently being used by that utility. But also Xendee's user interface is really good to be able to take something like a grandfathered rate from a facility that's been operating for a long time and kind of populate that into the model. And so this is extremely powerful, especially if you're like me 3 years ago, just jumping into interpreting the words and the meanings written out for tariffs and being able to put them into an actual working model. So I want to bring up these uses of Xendee, which are not microgrid based, but are wonderful for being able to model different scenarios for assets that customers might be investing in, like storage. Again, we talked about those, the geneability tool to be able to update rates and tariffs into the project. But when a client who may have solar already is looking into the feasibility of using storage for demand response, again, Xendee has the ability to import some of those demand response programs from existing utilities if they're already in Xendee. Otherwise, you can create it for yourself and represent different strategies for being able to leverage an investment like energy storage for your facility. The other thing I would say is toward a net zero energy conversation, the ability to manage load through a load shedding scheme is another way that Xendee can be used to represent opportune times for shedding load during non-outage periods and again, creating feasibility for net zero energy strategies. I will say again, it's not the end all be all for load shedding. Load shedding is a huge conversation that goes beyond just distribution power systems. It is the integration with mechanical systems like building management systems or lighting networks to really kind of dial in the way that you expect a facility to work, but then jump into the conversations of how you're going to get to those points. So these are the different feasibility analyses that we use when we talk about decarbonization and net zero energy. There's a lot here to digest, but I think what I appreciate about Xendee is both like a year-long user of the license is that when I do something that Xendee may already have seen not work for other simulations, it provides me warning data, which I think is wonderful because then before I ever spend 30 minutes waiting on a simulation to finish, I already know that this is probably the thing that's causing me the holdup. The reduced costs and the reduced CO2, those are two different simulations that are going to give you two different outputs. And it's great to be able to go in and understand the differences between those two things. As an MEP firm, we're always going to be consulting on what the best strategy is. And that's not always, the reduced CO2 answer in these decarb cases because there's always a financial aspect to it. For me, the time series data as an electrical designer is probably the most important thing because I'm definitely trying to interpret the way that the system is intended to operate. At any point during this process, if I find that there's something that doesn't make sense to me, again, what I appreciate about Xendee is that it'll not only write out for you what it is you're looking at, but it'll also provide you videos on typical use cases for these different things. And if at any point, you find yourself held up with not being able to get the outputs that you're looking for, requesting support will capture that project, and you can ask your question with really good technical support and feedback. I'll jump to the results here just to highlight a few things. Spent a lot of time kind of working through different opportunities that may exist, refining what the technologies invested in are going to be like. But I've always said garbage in equals garbage out. You really don't know if everything that you've been able to pre-populate from before is exactly what you're looking for until you get these feasible results. And then if you don't get a feasible result, it's really awful not to know why you weren't able to obtain the results you were looking for. And Xendee is wonderful in being able to provide you a report as to why things are infeasible. Again, sometimes this will lead to maybe not another simulation, but it may lead to expert mode and having the conversation about, what in expert mode am I able to tweak to be able to achieve what it is I'm trying to accomplish. So I bring this slide up just to say, this is 27 simulations on a recent project that I was working on. It takes time and patience to be able to get through not only setting up the project, but interpreting and making sure that the results that you're receiving are what you're actually looking or what you're actually expecting. So once you've finally gotten your inputs correct and you're looking at your outputs, Xendee is wonderful in being able to provide you all these charts and graphics. This is not where we typically stop at AEI with reporting to a client. We basically take the hundreds of CSV files and extrapolate the information that we're trying to represent for our clients to gain the confidence from them, and that the tools that we're using, we both know how to use and know how to interpret so that the client feels comfortable with the decisions that we're helping them to make. So I have two kind of cases shown here, one on the top right, which represents how we use Xendee to be able to optimize, again, the investment in energy storage for demand response and how much savings a project or a facility could expect to have based on the different sizes of energy storage investment. And then in a separate case and project, I have basically the extrapolation of all the different technologies that we're planning on being invested in for a microgrid and how those would interface with each other to ensure that there was going to be a successful 2-week ride through during an outage period. So I'll jump to some use cases that we have here at AAI. One of the projects which I've used Xendee for in pursuit is for a critical facility that's being constructed in Southern California. It's projected to have 12,000 gross square feet of office space, 10,000 of warehouse space. It is a net zero energy project, which is utilizing load shed scheming at the distribution level. There is a microgrid that's going to be used with this facility to include all the technology shown here. It is pursuing LEED Gold, and it is a design build project, so it's going very fast. And I will say that having Xendee on our backs to instill, again, the confidence in our client that the design that we're creating is going to meet all these different criteria is hugely important, not only for the pursuit, but the design, and then also for the construction portion, where we basically take this Xendee model, which has been optimized, and we provide that to a microgrid controller vendor and say, this is the way we anticipate a system working. Now, how do we program it such that it's able to accomplish these same objectives? So again, I will say Xendee, wonderful for asset optimization, trying to fine tune the right sizes for the technologies that you're going to invest in, but it opens the conversation next for how you're going to program said microgrids to be able to accomplish all the different modes of operation that are expected to be a part of the design. Brett, do you have anything you want to add about this before I pass it over to you?
Uh, no, I think we can jump into the next one. I think I was looking at summary there.
Okay.
Yeah, so zooming out a little bit more, our next case study here is a cold climate transit facility. It's actually multiple facilities where they're looking at decarbonizing their bus system and moving to battery electric buses. So as part of our work with them, there's a campus planning effort for 6 buildings, including administrative, maintenance, bus storage facilities. A second site that would be looking at for a depot charging hub of up to 15 450 kW fast chargers for their battery electric buses. Looking at a variety of technologies to meet their goals. They want to be all electric for their entire facility to align with their bus electrification goals. It's a cold climate here, so looking at cold climate heating solutions. Mass systems are introduced into the system to adding another kind of dynamic to our analysis. And then we've got our distributed generation assets here that currently have 120 kW of bifacial PV going in at their charging hub site. So this is really a perfect project that overlays the benefits of using a tool like Xendee to solve these complex decarbonization challenges. Lots of diverse load types on it, not just the building decarbonization, but also the fleet vehicles that we are charging. So different profiles, understanding Xendee's expertise with vehicle charging and being able to tie those in and look at scenarios was enormously helpful. The different types of building needs, being able to match that to what our energy generation could be at very constrained sites. So we have one of the sites is net zero ready for the building facility operations, and then there's the bus charging on top of that. So this is kind of taking that step back from 1 or 2 buildings and looking at more of this community electrification perspective. We studied a variety of options here, both with assets that would be owned by the transit organization, in some cases assets that would be owned by the local utility, looking at the space requirements, what were the benefits. The 15 bus chargers is a little bit more than 6 megawatts. This is a fairly good sized city, but at 6 megawatts, it was one of the larger point sources of power in the city. For to have all 15 buses at one time roll up and be trying to top off their batteries before they go back to their routes. So it was really of interest to the local power utility, how we were coordinating that and working with them and to find an efficient solution in a part of town that was already very congested. The bus system wants to be in a place that's accessible and efficient for all of their routes, which puts their charging hub right in the center of downtown. So they're competing with all the other utilities there. But also this particular location has a Corps of Engineers project that's putting a 20-foot wide underground river, essentially stormwater management concrete pipe to divert some floodwaters from north of the city. So we're trying to coordinate 6 megawatts through of utility power to this site amongst all the other utilities, and then this enormous Corps of Engineering project going in. So being able to optimize that and show the options to the client and the utility, and to right size those over time was enormously critical to this being a success, particularly in our initial phases here. And being able to do that rapidly with a tool like Xendee and pull in those different technologies was really key to the first several stages steps being successful, as you can see with this fast charger installed here. So our next case study is zooming out once again to a campus level. So this is a higher education campus. Here we're looking at, we've gone from, the several hundred kW, maybe 1 megawatt scale, took it a little bit higher to that transit facility that's, the 5 to 10 megawatt. Here we're in tens of megawatts of power that we're looking at for a large higher education campus. We're working with some, industrial campuses that are upwards of 100 megawatts of power that they're looking to how they provide and manage for their systems. But for this campus in particular, they're looking at full electrification of the campus in incremental phases to meet their internal goals, both driven by students, faculty, and also the surrounding city and community that they're in a partnership with. Interesting here, they were looking at options to island critical services on campus up to 5 days or 120 hours. So a very significant resilience scenario that they were looking to study options up to that to overcome. I know that's really a function of some of the power reliability challenges that they had working with their utility in order to maintain safe conditions for the community during extreme events. So as part of that, there was a number of load shedding strategies that we needed to look at and study. Xendee's, as Santos mentioned, that load shedding tool was really so helpful to be able to look at those and then immediately see what the impacts to the assets are to meet those. Conversion of existing systems that are in place here. So really phasing that out over multiple steps with a steam cogeneration system, moving away to that to electric hot water and other assets to support that reliable power asset that they have on campus there. That led us to look at a variety of different strategies for technologies to implement, and really joined by several other studies that were leading up to it and in parallel, but including all mass photovoltaics on campus, fuel cells, engine generators that might run for short periods of time, ground source heating, various different styles of heat pumps to produce hot water to the campus in lieu of steam, different storage technologies, so more conventional hot water, chilled water storage, battery energy storage, but even things as I'd say one of the more interesting technologies that we studied here was a micro pumped hydro storage solution where this campus actually has more than 1,000 feet of elevation from the bottom to the top. So as part of some of their internal research, they were very interested in this idea of pumping water up to the top of campus and then running it through a turbine to use that power during peak times or to help level out microgrid system during their islanding modes. And a very niche kind of specialty system, but what was really great about working with Xendee's customer support team is we were able to take something that's not really utilized in this scale very very often, and it is very kind of unique to the campus that we're looking at. work with the expert mode to pull out the analysis of all the other assets that we're looking at and compare those different dispatching options and technologies together, pretty seamlessly, taking the exports out of the expert mode and then adding in that, focused system analysis on the micro hydro storage option. And so, really just in summary there, Xendee's been a enormously helpful tool in order to, take what often previously we would have several tools doing very specialized analysis in different systems and then kind of bringing those together. Xendee lets us take a larger chunk of those together and rapidly work through options, and then still gives us the flexibility to tie into our other tools, which we found has really been unique and able to solve these complex decarbonization challenges where there's such a wide variety of applications that we're looking at from the building scale to these campuses that have residences, research, recreation, swimming pools, all sorts of different diverse load needs and environments with elevation. As Santos said, getting the infrastructure in the ground for these different technologies can really, the cost of that can sometimes be the deciding factor between the technologies and how distributed they are. In some campuses, we're working with very corrosive soils that's driving up the cost. We have, some campuses that have unstable sandstone formations that they're built on top of that really require special constructions and entrenchings to be able to support, which dramatically changes how far out our assets can be on the campus. Changes the cost effectiveness of different solutions, and so being able to take all those real world constraints and information and then to analyze those quickly with Xendee is really critical to being able to solve these complex challenges as we saw on this higher education campus.
Right. One thing I wanted to just to mention that I don't think I mentioned earlier, but when we talk about decarbonization present day, and we are also talking about future growth, we are also talking utility constraints. And that does play a huge factor into the types of technologies that we're investing in to be able to alleviate what type of distribution capacities exist, like it exists and to the client for the future growth, and talking about different strategies to be able to meet those energy demand needs. Efficiency gets us, a good portion of the way, but also just these different technologies get us the rest of the way. Okay, Lulu, that's the end of our presentation. I know that normally you have a Q&A segment during this portion. I'd like to kind of open it up.
Of course, so let's open it up for questions. You can post in the chat or you can raise up your hand and we'll make sure we cover them.
Excellent presentation on the integration of things, and we're doing similar things up here in Canada. Because we have a decarbonization, but my question as I put in the Q&A is, how do we address the building envelope improvements as part of this holistic approach? We look at mechanical, electrical, but literally things like the building envelope and windows and secondary, they affect the loads that we have to meet. How does Xendee bring that into it?
Yeah, I can touch on that one. So how we've been handling the load reduction strategies on envelope measures as an example of that is typically I'll say AI. We're doing that analysis in a energy modeling software, and then we are studying those options with that that software to get that more fine-tuned analysis on the envelope, and then we'll take the load profile from there and import that into Xendee. So having that load profile builder is really great to take those inputs from other tools. We're studying the demand reduction, and then have a nice, really straightforward feedback loop to the microgrid or the distributed energy resource analysis there.
Great. So here's another question from Logan saying, can you talk a bit about the implementation of the fuel cell technology on the last slide?
Yeah, so fuel cells are a number of technologies that we looked at for this project. There's some interest in the fuel cells' ability to switch to alternative sources of fuel over time. Fuel cells have very specific operating constraints, and so Xendee's worked very closely with some of the leading fuel cell manufacturers to capture those, and then we worked with the specifics of this project to study those options. Certainly, significant space infrastructure, electrical distribution, routing impacts that were considered by the team in terms of implementation. Kind of in the more detailed analysis after we took it out of Xendee there, but yeah, the fuel cells are a little bit of they've been around for a while, but continue to be a emerging and growing technology that we're seeing in the marketplace. So we're starting to see them become more and more competitive economically. There's some advantages there from the ownership structure and having those provided as a service. So really a great kind of tool to have in the toolkit to play with the other assets there. Off more of a base load type of power generation on the campus. So fine tuning those conditions, which is really easy to do in Xendee. You had a lot of flexibility to control the operation of those, and we were able to work with the manufacturer to get a comfortable type of operation where we could start to see, okay, how does batteries or other supporting systems playing with the fuel cells to maximize their effectiveness.
Yeah, I'll add to that too. When we went into model for the fuel cells, you're talking about, present day fuel cells, which are using natural gas, but then the future integration with hydrogen. And it does change the efficiency of those fuel cells. So you're kind of creating two separate models to say, like, this is what you're going to expect for today until you get the infrastructure to be able to support the conversion over to something like hydrogen, and then the way that the system is going to change for that conversion. So I do appreciate having Xendee to be able to just show those two use cases, and then we again are able to take that and provide it as another visual for the client to understand.
Yeah, and I don't know if we said it as explicitly, but Xendee has the combustion and the process emissions from the different types of technologies too. So we could look at the fuel cells with different input fuels to see how that emissions changes over time and with different options for fuels there, which was enormously helpful understanding the availability of certain fuels now versus what might become available later and how that would change the dynamics over time.
Perfect, thank you. So we have a couple more questions. Edward is asking for specific installation examples.
And I would ask back to Edward, Toward which part? Do the decarb, net zero energy? I guess both. I mean, for me here, and again, I've been at AEI for 3 years. I see most of the effort when it comes to decarbonization as a part of university campuses, privately owned industries that are trying to create a better portfolio for themselves and a brighter future for not only their research tenants, but their students and their faculty to know that they are working toward these decarbonization efforts. Energy such as university.
Yeah, I can answer that one, Santos. So the one that we have shown on the screen now is currently in design, so in early steps. We have a number of university decarb projects. I'd say probably one of the ones we're most well known for is some of our work with Stanford. Decarbonizing their heating system there. So primarily working on the mechanical side. But we're working with a number of universities on the power side. Conventionally, we've done a lot of cogeneration systems in the past. So that's been the I'd say historically most of the university power generation has been in photovoltaics and natural gas cogen systems, and then engine generators, primarily for standby uses. And so we've started to see more and more examples of battery energy storage, starting out in smaller scales, but that's continuing to grow. Fuel cells, we've again seen some smaller implementation there, but quite a bit more on the healthcare side, particularly in California, for implementation of fuel cells.
Perfect. So next question might be related. It asks for examples of new construction projects that are looking to future-proof their facilities for net zero. And kind of like a follow-up question is, what kind of approaches are they using?
Yeah, so there's a couple. I'll go to the transit facility. So their net zero transit hub downtown is aiming to be net zero. That's where they have 120 kW of bifacial PV on the building, and then they're going to continue to extend that over canopies where they're going to do the bus loading. I'd say most of the net zero projects are still looking at it as at an annual basis, so exporting versus generating as much power as they're using over the course of a year. As generally when you start exporting back to the utility, in most cases, you're seeing a pretty significant drop off in the cost effectiveness of those systems. So we're starting to see more and more facilities include more battery storage to use more of that on site. The critical facility Santos showed in our first case study is having a significant amount of battery to be able to run the entirety of the critical operations off of the battery system in an islanded mode. We've got another manufacturing center that has a similar system that's designed to run entirely off of battery and photovoltaics on site. Again, primarily the critical operations is what we see most facilities were focusing on there, and then they also have engine backup to that as well. So most facilities we're seeing still using, particularly for the islanding or kind of resilience events, a combination of gas and electric sources. But we're starting to see more and more facilities, have that growing comfort level with the all electric during off periods, which allows them to to have more of that storage to export less and less during normal operation. So we're starting to see the trend towards a not a net zero from an annual export perspective, but to get closer to that from a monthly or daily perspective. But still not quite there yet for the vast majority of projects.
Great. We have a question from Dan asking, what DR product have you seen has the best ROI for off-the-grid islanded projects, short-term and long-term?
I'd like to start with this question answer because it really does pertain to the intention of the project. Being off-grid and island, where we've seen that kind of be the conversation to start out with, is the location of a facility, be it like a data center, for instance, is away from any existing utility infrastructure that may exist. And so we really have to consider what base load opportunities are currently on the market and make the most sense when it comes to ROI. And natural gas combustion turbines tend to be that investment. The natural gas infrastructure may not exist, but that is an investment based on price that makes the most sense for something as large as a data center or as large as some remote facility where the utility power lines have not been able to get to them yet. And then from there, PV makes the most sense here in the Southwest region. So it's going to be the least cost option. And we always consult to add some form of storage because PV is only half the coin. If we're over generating, we want to capture that, distribute it, and make the most sense for being in an off-grid or islanded situation from some of the capacity that has yet to be created. Brett, do you have anything to add for that?
No, I think you covered it. Yeah, depends how off-grid. If you have gas but no power, usually gas is still pretty cost effective depending on where you are. If you're don't have gas or power and your alternative is shipping in diesel by boat train or plane, you're probably going to see a good return on investment on on-site renewables, on photovoltaics and batteries, and
I want to bring up
smaller.
Yeah. I want to bring up this next question because I know that we're getting close to time, but it kind of relates to this off-grid ROI opportunity. Here, in the Valley or in the state of Arizona, we don't typically go through too many natural catastrophes that would inhibit the ability to use something like solar PV in stormy places or wind and not windy places. But SMRs are a big conversation, at least here in the state of Arizona, for opportunities to be able to provide base load. And that's kind of something that we're exploring right now. Just in general as a firm for when it comes to feasibility so that we can consult on what exists currently commercially. A lot of these reactors are still in the research approval phase. There's tons of legislation that's surrounding SMRs that inhibits the ability to be able to invest in them the way that we're wanting. So it's more than just can the technology, which may be available, provide for that, but does the legislation, does policy, do all these other different portions allow for something like that right now? So I think getting the product out into the market has been kind of the big push for now, and now working through the policy and legislation and NRC. Those are all kind of the next steps to being able to turn those into real world applications. Mind you, here in the state of Arizona, we manage Palo Verde, which is the nuclear operating plant that doesn't exist next to some large body of water, and it is successful in operating, providing for 5 states. So I think it's definitely in AEI's wheelhouse to have these conversations about the feasibility of SMRs, and Xendee is kind of the only tool that I know of right now that really is able to throw out some projections for modeling those and making them real world applications.
Great. Thank you, Santos, and thank you, Brett, for answering all of those questions and for such a great presentation, for speaking highly about Xendee, and thank you all for attending the webinar. I will be following up with a couple of you. I've mentioned in the chat with some additional material based on your questions, and we're also gonna send a recording of this presentation in case you want to review it or share it with someone else in your team. Other than that, stay tuned for future webinars with us, and we really appreciate your attendance today. Thank you all so much.